Hey YouTube, I'm doing outstanding, and today we're looking at the solar system at a startling 1 second per second. Actually, it's a little less than 0.9. Yeah, everything seems to be moving a lot faster than that, if you ask me. But let's get down to Earth. Wow. Look at that. Now look at the distance between the Earth and... where's the fucking moon? Where the fuck's the moon? Am I stupid? Is there no fucking moon here? Well, I guess we won't be looking at the moon today. Lame. Wow, look at those. The clouds are like coming off. Wow. A lot of work went into this. I mean, look at that. Look, there we are. It's like Portland right there, I think. Wow. Is that... I thought you couldn't see the light from space. I don't know why I think that. I don't know. I swear I read somewhere that you couldn't actually see it from space. Depends on how far into space you're thinking of, but... I feel like this is definitely too far to, like... clearly you're not really seeing the light. You can't even tell that Earth is there from out here. But... so this is Universe Sandbox 2. Wait, was that Maki Maki? Hey, it's Maki Maki! Look at this. Ooh, it's dark on Maki Maki. Make. Look at that. That's crazy. So, we're gonna fuck with Earth. And we're gonna do that by fucking with its settings. We're going to now make it twice the mass of Earth and see how it affects everybody around it. Here, let's go ahead and change this to 1 hour per second. Not much, I would say, has changed. But, let's make it 10 times that. You'll start to notice a difference there. Eventually. Here, how about 1 day per second? Be a little bit more noticeable. You'll see that Venus is being pulled out towards us now. Ooh. Mercury doesn't care. Mars doesn't care. Venus is literally being pulled towards us. This is exciting. Oh, it's now 20 Earths of mass. Oh no? I mean, Venus has definitely been pulled out of orbit. 200 Earths. I mean, that's a lot of mass. I don't think it's going to affect anybody out here. But it should definitely... yeah, look at Venus. It's got an uneven circle here. What about Mercury? Ooh, look at that. Going to slowly be pulled a little bit further out. What about the sun? The sun's just solid. It's all good. Oh, look at you. You're being pulled in ever so slightly as well. Okay. Crazy time. Let's speed it up to twice the speed. Oh, really? Okay. I guess double the speed of Earth is enough to leave the solar system. Okay, so let's bring it down then. Let's bring it to about there. I'm really just fucking around, so, you know, I like fucking around in this. I would do it in VR, but it's actually a little bit harder in VR, believe it or not. Let's change its density. Oh, wait, that makes it huge, doesn't it? Make it tiny. A very tiny radius, but still weighing 200 Earth. Oof. Look at that. Alright. You know, it's... doesn't make much difference how dense the material is, I guess. Fancy. Oh my god. I mean, that's more realistic, I guess. I'll leave the density there. Let's multiply the temperature by 2. Why not? The average surface temperature is now 34 degrees Celsius and rising quite quickly. I'm surprised there hasn't been more, what about you, Palace? Are you affected at all? I feel like you have to be. You know what? Let's go for another mass drop. Boom. Boom, boom. Ooh. What is that? It became red. Oh, because it's now a star. Not literally, but... it is massive enough that it's become dangerous. I don't know what I'm doing there. Oh, now the sun is being pulled into it. Oh my god. Look at that. That's insane. Now we're talking. Now it's getting crazy. Now the sun's coming right at us. Ooh. Oh, that's scary. Will the sun be able to orbit us? Will we orbit in a dichotomy? Let's find... oh god. Poor Venus. Look at Venus. The temperature on Venus has risen very high. Ooh, is Venus gonna collide with Earth? Oh, not quite. But it is in an infinity around the two. Nope. It's been lost. Oh my god. But look at the temperature. Where does it go? 500 Celsius. Let's just drop that down to 1. Oh, immediately heat it back up. Yeah, it can't help but immediately heat back up. What about you? What are you at? Fucking hotter than hell. Earth now has a mass of 4 suns. And you can see stuff is just kind of dodging Earth at every whim here. Oh my god, Venus just got destroyed. How's Earth doing? Earth is just out there absorbing. Oh my god. Now let's look at the further out stuff. Is anything out here being affected? Not enough. Let's change the mass. Times 10 again! Oh. Oh man, now we're really seeing stuff being affected. I mean, look at Jupiter, it just suddenly went... But you see here, this is just fucking insane. A lot of damage going on there. I think that's the remnants of the sun. Yeah. And it's moving fast too. I mean, let's drop this down to 1 second per second. And you'll see it's not moving, you know, that fast, but fuck, that's scary. Scary nonetheless. Here, how about 1 hour per second. Like, every hour it's moving that, like, whoa. That is a blazing speed. How fast is that moving? 500 kilometers a second. Jesus. 1,000. Accelerated up to 2,500 kilometers a second. 2,500 kilometers a second to miles per hour.
2,500 kilometers is equal to 5.592 times 10 to the 6 miles per hour.
What that actually says here is 5,592,340.73 miles per hour. That is a lot of speed. A lot. A blistering speed. Blistering. Not blistening. Oh my god. Ooh, there's a little bit of a stutter there. It's slowing down. But it's also not weighing the mass of the sun anymore. There we go. Now you're back up over the sun. And you're still 41 suns. You're hardly affected. No, you're definitely still heavily affected by the sun. Yeah, how frightening that would be. Just, like, oh my god. Alright, how is Jupiter and Uranus doing? Is everything kind of moving in? Not at a blistering speed, that's for sure. How fast are you going? It's hard to tell. Oh, here we go. 170 kilometers per second. Here, let's just set that to 0, and then you'll immediately turn around. Let's go back here and set that to 1. Nope. 1. Oh my god. It's having a tough time keeping up. 1 day. Oh my god. It's because so many things are happening and they're not clean calculations either. Ooh, you see Mars just got fucking jettisoned. Mars is gonna tear itself apart. What is that? It must be like some sort of... Vesta's come in. Oh, here we see Iris. The Sun still weighing 1.42 suns. Earth still weighing 41.7 suns. How's Jupiter doing? Jupiter's headed right for it. Tell you what, let's do it again. Let's just do ×2. Oh shit. Oh my god. Things are just getting more and more violent. Look at that. Oh, and now it's an Earth Nova remnant. It went supernova. Let's disable that. Oh my god. There's hardly anything left. Oh my god, it's legitimately just a black hole. Oh my god. But Jupiter is still... How much does it... It weighs 167 suns. That weighs 1,600 suns. Eventually it has to stop calculating in terms of the sun. Nope, I guess that's it. Wow, look at that. But what's crazy is... Oh, here, let's turn on calculated radius. No? That didn't change anything. I can change the density to like infinite, and it just, it's so small. Except that it's like absolutely fucking hulking. Oh my god, look at that. It's 304 Earths. Ooh, it just dropped down to 303. Oh my god, Jupiter, what's wrong? No, that's the sun? What? Fused with Jupiter? I don't know what's going on. I clicked on 121 Hermione. No, I want Jupiter. There we go. Let's get you a few thousand sun there. Oh, and as you can see, things are starting to fly at it now. Ooh, including Saturn. Boing! Which is now somehow escaping a black hole. No, I know how. It's not quite close enough. Oh, and now this one's become bigger than the Earth Nova remnant. But it's sucking it in. It's passing right through each other, but doing nothing. And now this has sucked up everything. Woo! Oh, what a waste of time. Let's look at something else. Let's see. Oh, you know what? A really interesting one is physics. Earth tidally locked. Wait, Earth Nova remnant. That's still alive? Oh my god. Let's see. Collisions, explosions, solar systems, planets, exoplanets, fiction, human scale, choreo, systems, experiments, Jupiter in between suns, no. Encounters, grids, chaotic orbits, stress tests. Ooh, stress tests. Why not? Galaxy collision high res. That sounds like a bad idea for recording a video. So this is on a scale of hundreds of almost millions of years per second. But I believe this is our galaxy in the Andromeda. You see we start to like tilt up there, and that would be frightening. Oh my god, could you imagine being like right there that second? Here, let's drop it down to 1 second per second. Wow. Beautiful. Bright. Holy moly. Yeah, I'm pretty sure when two galaxies collide, everyone's just dead. Everybody, everywhere, dead. Ultimately dead. Yeah, just a little bit of the Milky Way here. Oh my god. Yeah, we'd be utterly destroyed. I do not look forward to that future. Oh yeah, there we go, that's... Spiral galaxy, ring of galaxies, galaxy cluster, supernova in a galaxy. Let's look at the core stuff. Oh, the Tesla Roadster. Why not? Let's look at the Tesla Roadster. Look at this little guy. Sent from Earth. On February 6, 2018, SpaceX performed a successful test launch of their Falcon Heavy rocket, the most powerful rocket currently in use. The launch was intended as a demonstration of the Falcon Heavy's ability to launch a payload into an orbit that could reach Mars. SpaceX also successfully landed 2 of the Falcon Heavy's reusable booster engines, although the central core crashed during its attempted landing. As part of the test, the Falcon Heavy rocket carried a dummy payload to demonstrate that it could launch a large mass onto the required orbit. For this launch, SpaceX chose an unusual dummy payload, a Tesla Roadster electric car belonging to SpaceX and Tesla CEO Elon Musk. In a press statement released before the launch, SpaceX explained that it wanted a payload that was fun and without irreplaceable sentimental value. While the Roadster will not land on or orbit Mars, its current elliptical orbit around the Sun will take it beyond the orbit of Mars at its furthest point. It is worth noting that this current simulation is slightly visually incomplete. Our payload object, the Tesla Roadster, depicts just the car, where in reality the Roadster is attached to the second stage of the Falcon Heavy center rocket. In addition, the mass of the combined car and rocket is roughly 4 times that of just a car. But because of an object's gravitational acceleration is not affected by its own mass, the trajectory of the roadster in this simulation will be identical to its real-life counterpart. So, we are currently going about 2 hours a second. So you can see... Oh, how detailed is this? Oh, wow. I mean, it doesn't have all the asteroids, but that's okay. Pluto, Neptune, Saturn, Uranus, Jupiter, Mars, Earth, Mercury, and Venus. Cool, 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 cool. And then the Tesla Roadster. So if we zoom in on this little guy until we can see him, he's fucking tiny. That's what he is. God, that'd be such a cool view. But realistically, I don't think you would be able to see much of anything. Well, driving along at the speed of sound. How fast are we going? We are currently traveling at 33.3 kilometers a second. That's not as fast as I would have thought. How fast is that? That is 73,000 miles per hour. That's pretty fucking fast. I mean, the fastest car in history, I'm pretty sure. Jesus. Look at that. That's cool. They spent a lot of time modeling it. Clearly. So let's speed this up a little bit here. Continue to zoom out. So I thought I would bring it into orbit around Mars. No, I mean, I know it said not, but... It should bring it near Mars at the very least, but this orbit doesn't seem to match. I don't know. Now, obviously, as I speed it up, the calculations get less accurate, but it should bring it close enough to Mars that you could theoretically board it. I wonder if it will ever recollide with, anything. Okay, see, that definitely brings it very scarily close. You could have easily landed on Mars at that point. Yeah, I see that. But, I mean, that took a full revolution. We're talking about years. This is months per second. Oh my god. And that's years as in Earth years, obviously. Let's see, where are we going? I'll cut back if it ever collides with anything. Alright. I'm back. But, it didn't go as planned. 5,200 years has passed, and yet no collisions. 5,200 years. And no collision. That's pretty impressive. Now, if we focus on it, it's still at 270 Celsius, so it's fucking cold. That's just disappointing. To me. Anyway. Maybe not to you. But I was kind of hoping that at some point it would, recollide. It just never did. So you may be wondering, well, how did you simulate 5,000 years? It says months. Yeah, I sped it up. I was running it like 8 years a second or something like that. Which, yeah, sure, it's not as accurate, but it's accurate enough for something that doesn't matter. So, this is what I'm going to do. I'm going to change its mass to 1 moon. Now let's see if we get a collision. Probably not on the month scale, though. Woo. It's a lot faster. Wow, that's great. We can have something the size of the moon. Is it the size of the moon? Yes. Yes, it is. Not sure what happened there. I think my recorder crashed. It's all good. We're back. We're still following it. It's not doing a whole lot. It's now 10 moons. 100 moons. 1,000 moons. 10,000 moons. 100,000. Wow. How long until it's not counting based on moons? Oh my god. That's just a black hole, man. It weighs 26,000 times the Milky Way. But since there are no stars, you can't really see it. Here, let's add... just tons of stars. Okay. Is it? I don't think it's playing. Oh shit! They're just orbiting around the Tesla Roadster. And I set them free by dropping its mass. Oh, hey, look. That looks familiar. Jesus, how fast are you moving? You are traveling at 132,000 times the speed of light. That seems realistic. Ten times. Jesus Christ. How much mass wow, I can't really set it any higher, can I? Okay. Just drop it really far down there. And now it's going to be pulled around by them. Let's at least make it, 10 times the sun. That'll work. Here's a way I can just tell everything to stop. I'm pretty sure there is. Oh man. If there is, I don't know what it is. Fragment gravity. Gravity is stronger here. Oh man. I know nothing. It's okay. Field of view. You know what? I think that's good enough for this video. Thank you guys so much for watching. Hit that like button. Hit that subscribe button. Have a good one.